In today's video, I would like to see what it would be like to playback an event. So I think we can start with a GraphQL schema that plays back a range of events that we've already recorded in the space. So maybe this will be a mutation. We have queries here, we have mutations here. Oh, that comes to my attention. I'm not sure if we tested this thing. Update space. Let's look at the resolvers. Takes a space ID and attributes, takes a space ID and attributes, I think also updates, get space by ID. It looks like it would do the right thing. Anyway, we'll create a new mutation, this one called playback stream. Field playback, and it returns maybe a boolean, and we need the space ID. And we need the beginning sequence number and ending sequence number. Beginning sequence. This is a non-null integer. And I guess we can start with that. Then we can resolve that at space resolver and call it playback 3. So we'll go to space resolver and create, define playback that takes some root, some args, and I think some context. Okay, so args will pattern match to space ID, and the beginning, call it beginning sequence. Okay, so we have an alias for spaces. So we'll go spaces. Actually, what we want is the event stream, right? I think it is this. Let me put the spec in. event stream. Spaces event stream. That's what we want. We want spaces event stream, space ID, and the beginning sequence. So this will give you events. Let's say we have space equals spaces for O1 space, and then spaces event stream space ID. So we get that look like this. Okay. So what do we want to do here? We have this event stream and we want to play it. We could do space server .spaceServer .process event space ID and the original payload. Interesting. Yeah, this isn't the same, not exactly the same format as what we get. The payload timestamp type, I mean, almost. Could just construct this with message is, oh, okay, so we want to process each one. This would be num each, mobile, and the function with the event. Each one of these will send over here. Actually, this should probably be a context function. We need to launch a genserver to do this. A playback server. Let's just make an unsupervised genserver for now. So we'll create a playback server. genserver, restart transient. Not sure that we need to restart it at all, actually. Genserver. The child specification and how it runs on the ID. Restart defaults to permanent shutdown, for example. Let's not worry about this for now. Using logger. Don't know how it's used. Let's see. Timeout. Kick timeout. Okay, so the public interface. We're really just starting it. So what will we be given? We'll be given space ID. Starting sequence. Tuple maybe. ID. Beginning sequence. We'll call the start link with this same tuple. And the name will be I don't think we need a name. Nothing's going to send this thing a message. This is going to run by itself. And then I think it can just die. Terminate itself. I don't think it needs to be supervised. I'm going to start. So we're going to say OK, and it's going to be space ID and beginning sequence. Return a new state. Okay, and some state, I guess. Everything else is cast. So why don't we just give it a map? So let's just say options. And we'll just pass these into options. And here we'll get okay. Options. And this will be options. Compile. So now we can do vxr playback server dot start link with empty options. When we get back, look at this. Observer start. I don't think this works. We can't load this from within the container. Okay, so we've got this. Now what? Yes. Okay, so we're just gonna load something. So we're gonna expect that this is space ID, and beginning sequence. Then we're going to do the xr.spaces event stream with the space ID and the beginning sequence. This gives you events. And then if we begin immediately, then for everyone that's here, you want to throw them into the future. Example like this. Each one of these proper message. We want to transform them. And we can stick, okay, so we can just take well, this by default takes 100, which is fine, I suppose. Events, maybe we'll just take less. Let's just take 10. Look at the next one they come to pass. So these events, we need to map over them and change them up a little bit. We also need to know when to fire them, right? So each one of them has the event timestamp that's greater than the next. They're in milliseconds. So if we look at the first one, let's do this. Bag 5. Okay, so if you look at the first one, here's the timestamp. If this is now, then we have to say this is the actually, let me check something. What was that? OS something, OS timestamp. Yeah, what is this? OS timestamp. OS timestamp. No, that's not what I want. I want OS system time millisecond. That looks like it matches the number of zeros here at least. Okay. So we need a mapping. My time. Okay, so the first one here list first events. First event is that one. And current time is OS system time millisecond. To do terminate if events empty. So first event, assuming there is a first event, is this first event time, that dot event timestamp, event timestamp. So that kind of gives us the offset, correct? Because if this is the first, this is the first event time and current time, then offset is current time minus first event time, which is 20 million milliseconds. So our offset in milliseconds is current time minus first. Okay, so that's important because for every event that I get, if you take the first event time and play it now, how long do you wait for the next event? So first event time, this actually becomes your and current time is this. Okay, so the question is when to play second event. How long to wait? So assuming the first event time we're playing now, the difference between that is some 20 million milliseconds. And the second event timestamp, let's look at the second event timestamp, is just here. Second event time is this. So actually the first current time, first event time, this much, and second event time minus first event time, that's only 12 seconds apart. 12,000 milliseconds. So that's how long you wait, 12 seconds. So in each one, the first one subtracted from set is 0 delay. So you play it now. The next one, you throw it. Okay, this is delay. Throw it into future. So we don't really need kind of the current time. We just need the first time, and then we throw. When the last event comes in, we need to know when to fetch. Because we don't need to overfetch this. We only need to fetch right after that last section there. So we could give each one of these a counter, and when the counter is reached, then we know to fetch again. So we can have a, let's say, buffer size. That's how we do it. No equals. Okay, so the first event time is this. I think we need current time, the off, so then we'll do enum each for every event process send after send itself. The message shall be the I think we want some sort of count. Each with index and elixir. Index. Oh, we have the sequence number actually. So we can just pass the event. Then event, and here's the event. And then here we'll store the last event. Actually, why don't we just buffer them? Then we can reduce out of the list. So here we have the events. Then we'll say OK and return a state with events as events. All right. Then we'll send self process send self okay, so events has the first one there, so you want to have a list of rest and first. So we'll send ourselves a message of event is the first, events will be the rest. Something like that. So when we send ourselves, it's handle info, which looks like the event and the event, followed by the state. No apply and the state. Process send, did you mean send 3? So process send 3. Destination message options. Send is hi, no connect. When used, if sending message would require an auto connection to another node. Necessary. Okay, no connect necessary. How come I don't remember using that? Maybe it's kernel send? Okay, no process send, just send. handle info. Now what do you do? So we have the rest of the events in here. We need to send this event now. So what do? We will do the XR SpaceServer process event with the, okay, so we need space ID in the state. That, and what, the payload. Payload is the message is event dot type. The payload is event payload, and the timestamp is OS system time second payload. So we're sending this. Let's see, and then we look at the events in here. So first and rest of state events, and we needed to know how long it differed from the first timestamp. So initial time was first event timestamp. So that's how long you need to wait. Because you look at the second event, so you'll do process send after destination itself, message is event and first, and the time in milliseconds is first dot event timestamp minus state initial timestamp. And finally, state becomes state with the events as rest. So these should get played one by one. So when you initialize this, it sends this off immediately, and then it starts doing this. handle info. We should do something for when the events are nothing. What happens if you do first and rest pattern matching this? You can't get to it. What if there's one thing in it? So first is the 3 and rest is nothing. Okay. Maybe we do case over this state. Case over that as well. Case over the events. So if it's nothing, then send like self terminate or something. Does that work? Send self terminate. Oh. No. Elixir send self terminate. Not after no activity, just send an exit signal. Okay, so exit. Exit self reason. Done. Okay, that works. If you do have first and rest, then do this. So process in after, event first, and then that's the timestamp. Update this with rest. which will come back in here and then send that one. But then when you get to here, you'll have no more, and then you'll say exit. Okay, we'll do the same thing here, where we'll do case. And if you've got nothing, then just terminate. But if you have first and rest, then stop local start to return error resume. Returning ignore. Okay, so what you say ignore? Return okay in the state. Okay, I think this will work. Oh, okay. Hold on. We want exit here if there's more to get. This is something you would pattern match on if you get first and nothing over something like that. It does match. How about no. Okay, so if you still have something left, you'll pass the message. But if you had, let's say, nothing left in the second one, for example, say you had first and nothing here, yeah, we're going to send this away, but the events here, we should really try to grab some more. Another call here. So the event stream space ID, the beginning sequence will be the first sequence. this becomes either empty or this will work. So say that this is the rest. So state.spaceID. Alright, so this resolver playback probably just needs to start this genserver. Start link with the options, space ID, just test it out really quick. Okay, well, we'll figure it out tomorrow.